Distributed systems in one line are multiple computers working together, but they look like a single system. So you might be using some application and you'll be doing some activity on its user interface, but behind that user interface, that application would be sending multiple requests to different systems over a network. These systems work together and fulfill your request. These systems are present in almost every application you use today, be it G Suite, be it Microsoft Office, be it Slack or YouTube or Netflix or any kind of ride hailing service or any kind of fintech application. These systems are also the backbone of the gaming industry. For example, here's an architecture of how Netflix works. So you can see that when you stream an episode of your favorite show, it goes through multiple systems and then the video is streamed back to you. So all of these different kind of systems essentially work together to stream you your favorite episode. I leave a link explaining this architecture in detail in the description below. We need distributed systems because single computers have their own limit. A single server can crash, so if you are doing some kind of activity, the server can suddenly become unavailable. Besides that, a single server has limited resources, that is CPU memory or disk storage. So if you were to send multiple requests to the system might become overload and might be unable to serve your request. Besides that, a single server can only serve a limited number of users. So if multiple users are doing some kind of activity on the server might overload or might become unavailable because of the traffic. Meanwhile, in a distributed system, multiple independent nodes are connected via network and they coordinate with each other to achieve one common goal, and they do all of that while appearing as a single system to the user. Here, each node has its own memory, so each node can fail independently and it wouldn't affect the network. If one system goes out of the network or one system becomes overloaded, it doesn't affect the network in its entirety. And these nodes communicate with each other via messages, not shared memory. So, because of this system design and system architecture, distributed systems can scale horizontally, like they can scale using multiple nodes and then they can handle millions or billions of users depending on the kind of demand there is. They can also survive failures because the network doesn't go down if a few nodes fail or become overloaded. They can also serve requests with lower latency because they can spread across the globe and serve users closer to where they are. And they can also do multiple things at once, like search, analytics, streaming, etc. Because essentially, a distributed system is composed of multiple different systems working together, and you can assign specific jobs to each individual system. Now, in Web3, distributed systems are the default standard because blockchains are essentially distributed systems but on hard mode. So, in blockchains, you can see that you have thousands of nodes where there's no central authority, and these nodes operate over an open network and try to agree on one shared state. And since a blockchain is maintained by multiple independent nodes, this makes blockchains decentralized, in theory at least. Networks like Bitcoin and Ethereum are decentralized networks that are managed by multiple independent nodes, whereas services like Netflix, Google, or Meta are distributed systems managed by a single entity. So, whenever you do a transaction on Ethereum, it would look like you are interacting with Ethereum, the network as a whole, but under the hood, there are multiple different nodes that maintain the state and computation of the Ethereum network. Having said that, Web3 distributed systems or blockchains have their own issues as well. Like there's a problem of consensus, who will decide what is the next block. You also have state replication, where each node has to maintain a copy of ledger. So as the blockchain grows in activity, the size of data each node has to store increases with time. The network also has to be fault or adversarial tolerance because a node can either fail or lie. So the network should be designed in a way so that it works even if few nodes fail or they are operating mischievously. And then there's a problem with scalability. Like with Web3 systems, since all of them are essentially built on top of blockchain, each block of the blockchain has a limit to the block space, that is the amount of data it can store. And because of this limit, there's usually low throughput on blockchain, creating scalability challenges. Web3 distributed systems differ from Web2 distributed systems on certain key aspects. Web2 systems are operated by trusted operators, whereas Web3 systems are operated by trustless participants. Web2 distributed systems are mostly private network, while Web3 systems are more of public internet. In Web2 systems, you can roll back the state if something happens, but in Web3 systems like blockchains, you get immutability, so you cannot really roll back the state. In Web2 systems, the identity of the network participants are known because mostly these nodes are being operated by a single entity. But in Web3 systems, the identity of of the network participants is mostly pseudonymous because these networks are decentralized and trustless. In Web2 systems, failures are mostly accidental, whereas in Web3 systems, failures or attacks are a norm because these are open networks which anybody can see and try to hack. There are some trade offs of choosing Web3 distributed systems. These systems are slower and they cost more, but they also offer credible neutrality and they minimize trust in any single entity. So, if you are thinking about choosing a Web3 distributed system architecture, you might want to think along these lines. Web3 systems or blockchains work best when you need distributed systems without any kind of trust. There's no single entity governing these networks, these are decentralized and trustless, and the economic incentives for the network participants to work in favor of the network are baked in the code of the network itself. These incentives are often enforced via cryptocurrency. Now, how that's done is a different conversation in itself, and I'll cover that in some other video. Thanks for watching. You can ask any questions in the comments and subscribe for more such videos. Remember that nothing in this video is a financial advice. You have to do your own research.